This is going to be an advanced video about List.Generate function, which is a powerful function that is commonly used to create a sort of a do-while loop. Do-while loops are commonly used in object programming. The idea is to create a loop that is being executed until it reaches a certain condition. The following is a simple VBA code representation, and if we run this code in Excel, we would receive a list like this. So what is happening? We have an initial state of 1, and then we have a condition to repeat these two executions until x becomes equal or larger than 10. So in the first iteration, x equals 1, 1 is less than 10, so the 1 will be incremented by 1, so it will become 2, and at the same time, in the same iteration, range a1 will be populated with the value of 1. Then the iteration starts again because of the loop. X becomes 2, 2 is less than 10, 2 equals 2 plus 1 equals 3, so x in the following iteration will become 3, and the range a2 will be populated with the value of 2. And this loop will continue all the way until x becomes 10. In that condition is evaluated to false, and we stop the execution of the remaining of the code. While looping is used regularly in object programming, in functional programming, which M is a part of, looping is not easy to implement nor to understand. Nevertheless, there are techniques to implement recursive or looping functions, and using a List.Generate is one of them. Note to mention, these techniques, due to their iterative nature, tend to become very slow on large datasets or many iterations. Since PowerQuery is not optimized for those operations, you should rely on them only as a last available option. That does not mean you should never use them, because they are extremely powerful if used properly. Now, where to use and how to create? The general use of these functions is in dynamic outputs, where we do not know how many times our function should iterate to collect all the data. So the use cases could be web pages with pagination, APIs with previous next page structure, or APIs with a limited number of concurrent calls, and other structures in which we are unaware of the definite number of iterations. Mostly used techniques to create iterations are recursive technique, the one that we'll show next, and List.Generate function, which is the topic of this video. Now let's talk about recursive technique. The recursive technique is using @ sign to access the same function from itself until it reaches a certain condition. Following is a simple representation of the code. So let's go to PowerQuery and let's write new blank query. Let's call the query recursive function, and let's go to advanced editor, and we will write input variable will be x as number, function definition, and then we will write if x is larger than 10, then x, else and the name of the function, the name of the same function that we are inside, recursive function, and it will receive x and multiply it with 3. Okay, so let's click on done. We receive a function call. If we invoke this function with a number of 1, we will receive a number 27. So the function is receiving only one argument, x, and it's calling itself in the else argument of the if statement. So now let's see what really happened when we invoked this function with an argument of 1, and how did we receive a number 27. So let's head back to our PowerPoint, and this is our function, and it had 4 iterations. It had 3 successful iterations and 1 false. So what happened? In the first iteration, x is 1, 1 is not larger than 10, then the else argument kicks in, and the else argument is calling the same function, so the x is 1, and multiplying it by 3. So now on the second iteration, number 3 becomes the starting point, it enters the function, 3 is also not larger than 10, So the number 3 becomes multiplied with 3. So now we receive a number 9 as an input. The number 9 is not larger than 10, so we have a number 9 here. So we have a number 9 multiplied by 3, and we receive a number 27, and then the 27 is larger than 10, therefore it will become the exit of this function. And this is how we can introduce recursion manually with an @ sign. Certain M functions can also give us a framework for looping, and those are List.Accumulate and List.Generate. In this video, we will talk about List.Generate. But first, let's talk about the advantages of using this function versus classical recursion with @ sign, the one that we showed earlier. First, better readability of the code, then better performance, and lastly, unlimited call stacks. Now, what does it mean to have unlimited call stacks? While doing recursions, each additional iteration is added to the total stack of all iterations. So when we had like 3 iterations previously in previous example, those iterations can grow up to a million iterations. So each additional iteration is added to the total stock of all iterations. This stock cannot grow unlimited in size, so at a certain point the stack will become full and the procedure will stop. This is what can happen with classic @ recursion, but with List.Generate you're only limited by your computer memory. So with List.Generate you do not need to worry about the call stacks, which can potentially stop the execution of your query. So to conclude, whenever possible, use the List.Generate instead of recursive @ function syntax. We will explain List.Generate function on a simple example using an Excel file. So let's open our Excel file. Where is it? Let's go. Materials, Excel file. In it, we have multiple sheets, each with a structure like this. Simple structure. There are multiple sheets. So we want to transpose values on each sheet and append them one below the other. This Excel will grow in size and new sheets will be added in appropriate order from 1 to X. So eventually we will have sheet 5, sheet 6, 7, 8, 9, and to X. We want to iterate through those sheets and apply our function until we reach the non-existing sheet in the Excel file. At that point, the script should stop and return all the processed sheets up until the non-existing one. Just to mention that this task is only for demonstration purposes, and I know that there are many better ways of handling this situation than. This is in general a great example of M coding, since in it we will use both list and record type of objects, and each keyword, which is a sugar syntax for a simple function which accepts the current row as an argument. So with this example, we will cover most of the advanced M coding. In case you feel insecure about using records, lists, and each keyword, please revise those topics before continuing with this video. First, let's observe a function that we will use to unpivot each sheet. So let's go to our advanced editor. And let's go to fx sheet. We already prepared this function. At the moment, we should focus solely on the sheet to transform step. So this one. Ignore the first step and the last step. The last step is just doing the transposition, and the first step is a call to an Excel file in the location. So in sheet to transform step, we are injecting the input number variable to perform concatenation with the sheet keyword. So this one, this part. So we are using the input number, which is an input variable, and we are concatenating that with the sheet. So on each iteration, this number will increment by 1. The idea is to iterate the function until it reaches a non-existing sheet. In our example, that would be sheet 5. After it reaches sheet 5, the function should evaluate to false, resulting in exiting from the iterations and retrieving all the tables from previous successful steps of execution. And this is where List.Generate comes in as a building block for this solution. First, let's get familiar with the syntax of the function. So let's go to PowerPoint, and this is the syntax. For me, it was hard to grasp what each of these parameters mean until I started to think in the mRow context. The most important part to understand is that the List.Generate is an iterative function, meaning that it produces a so-called row context. In that row context, in each iteration, there are always two rows present, the current row and the next row. So now we will demonstrate this with a simple List.Generate function. So let's go to, okay, let's discard this. Let's go to a simple List.Generate and let's go to advanced editor. So this is our function. These are our four arguments. And after we execute this function, we receive this list. Now let's observe the function arguments. Let's go back to PowerPoint. So let's observe this function. This is the first. These are all arguments of the List.Generate. The first argument. This is the initial state before the function starts iterating and creating a list. This syntax of function invocation without arguments is a syntax of a function definition, meaning that List.Generate only accepts functions as parameters. One is the starting point that will change in each iteration, and it will change based on the argument on the third argument. Besides colors like numbers or text, starting input can also be in the form of a structured object like tables, lists, or records. The result of this argument in the form of a current row in a list or a record is going to be used within all the other arguments of the List.Generate function. And we can access this record with the underscore symbol. Now let's head over to the second argument. As we can see, each keyword is present in all other parameters of the function. Each is a sugar syntax for unnamed variable which is holding the current row of an iteration. The following line could be also written as this, where underscore represents the record from the current iteration of the list, or the initial state. Now this argument is taking the initial state of the current iteration and then does the comparison with the condition. If the condition is true, it stores that result in the current row of the list or pushes it to the optional fourth argument, to this argument, for further processing. If the condition evaluates to false, then the function execution stops and returns everything that was stored up until the last iteration that resulted in false. Now let's go to the third argument, each underscore plus 2. This is where it starts to become interesting. This argument is creating an additional row in the list, then pushes the result of its evaluation as the first argument in the next row iteration. After the result is pushed to the first argument, the iteration starts again and the conditional part kicks in, checking how the next row results evaluates against the condition. In this process, looping occurs until the condition is evaluated to false. And the last argument, each underscore times multiplied by underscore, if the condition in the second argument, in this argument, evaluated to true, that result is pushed to the last optional argument, so this is the optional argument, for further processing. In case we omit the last argument, then the result of the second argument is left as is in the current row of the list. If we apply that to our list, this is what is going on. So it has a lot of text, but it will soon become clear. We replaced the underscore sign with red numbers to emphasize what is happening in each iteration. As we can see, the initial state, starting position, is always entering the function and remains stable for the duration of the current iteration. So this number 1, 3, 5, and 7 are all stable for the current iteration. For the first iteration, the starting position is the only one that we explicitly gave as the first argument of the List.Generate function. So this one becomes the starting point. In the second iteration, the initial state is altered by the next row expression. So this expression altered the following iteration starting position. So now it became 3. Because of this, each 1 plus 2, the starting position became 3. And the loop starts again. As the function is looping, it is generating a list output as shown to the right of the picture. So in the first iteration, we had only one we had only one row in list, which had its value of 1 because of this evaluation of argument evaluation. In the second iteration, the list has 2 rows, and the result in the second row is 9 because this condition evaluated true. Therefore, next iteration will be 5, but we also have this optional argument which is saying that if this evaluates to true, then push this result to the last argument and multiply it by 3, or multiply it with itself. In the third iteration, because of this argument, the starting point becomes 5, and 5 is entering into all these other functions or other arguments. The 5 is still less than 7, so the 5 will increment by 2, but the result will be altered by the optional argument and it will become 25. In the last step, 7, result of each 5 plus 2 is entered and starting point, and 7 is not less than 7, therefore the other arguments are aborted, and we receive list as it was at the moment of the last successful iteration. Now that we have become acquainted with the List.Generate function, let's see how we can utilize it to perform the task from the beginning of the video. So we have an unknown number of sheets that we need to transform, and we wish to use the List.Generate function to store all transformed sheets until we hit a non-existing one. After that, the function should stop and return the transformed tables in the form of nested tables inside of a list. We know the function we will use from the beginning of the article, so this one. Okay, let's go to advanced editor. So this function. We know that it receives only one input number that will concatenate with the sheet text to perform the sheet iteration. Okay, and now let's go and observe how to implement the solution to a dynamic number of sheets with List.Generate. We will open a clean sheets advanced editor query. Let's focus on the first step in the query, the source one. So this one. It consists of a List.Generate function, and now let's explain each argument of the function. As we mentioned earlier, the initial state can be any scalar value or structured type of objects like tables, records, or lists. In our case, we are using the square brackets syntax to create a record type of object. This object is holding 2 columns named sheet and function. Sheet column has a starting value of 1, and the function column starting value is function invoke with an argument of 1. fxSheet is the name of the function we created earlier. Now let's go to the second argument. This step is taking the record from the initial state and checking if the fxSheet function that is stored in the column named function is returning an error in the current iteration step. If the function is returning an error, then stop execution, else continue with the next argument. And the next argument, so if the condition is evaluated to true, then add a new row to the list and set the initial state of that row to the following expression. So to this expression. So we again create a record type of object. For a sheet column, we set a new initial state to be the current sheet value of, which is at the second iteration number 1, and we increment it by 1. So we get a new starting position of 2. And for the function column, we also set the next iteration to be fx sheet of the current record of the iteration, which is 1, and we increment it by 1. So the initial states will change with each iteration as follows. So let's go to iterations. So in the first iteration, initial step is sheet 1 function fx sheet 1, and for all the other iterations, we increment this number by 1. So this is how the initial step will change its position regarding the step of iteration. Now at the 5th iteration, the condition will evaluate to false, since in our Excel file we only have sheets up to sheet 4, so the function will exit and we will receive a list containing nested records. So if we go to advanced editor, we click on done, and we go to source step, we see that we have 4 records, each holding 2 columns. One column is named sheet and the other column is named function, and the function column is holding a table variable. If we expand this, and this table variable is the processed table or unpivoted or transposed table that was transposed with this function. In this example, we omitted the last argument, therefore returning the whole record of the current row after it evaluated to true. In case we wanted to further process the result of the evaluation, we could use the 4th argument. For example, if we needed only column 1 from nested tables and we also wanted an additional column with the sheet number multiplied with an outer variable, we could write the 4th argument as follows. So let's see this. So we have this outer variable, which is something that is coming outside of the function or outside of the query or the List.Generate function. And then we have a record, and then we have a function List.Generate with 4 arguments. And the last argument is storing in the nested list column only column 1 from function column, so only column 1 from this column, and also introducing another column called multiplication, which is a sheet number or the number of the current iteration of the record multiplied by outer variable. And as a result, we will receive a list holding nested records, each record holding 2 columns named nest list and multiplication. Nested list is taking just column 1 from the table output, while the multiplication column is combining the result of iteration with an outer variable. Yes, this is possible. And it is using it to produce the final output. The last one is bringing even more juice to the function, so the applications and business problems you can solve with it are numerous. Just remember that you must use recursive functions with caution, since they tend to become slow if used incorrectly. In certain situations, like with nested List.Generate, you can utilize the list buffer to significantly increase the overall execution speed, but that won't help much in case there are too many iterations or the dataset is simply too complex. And try to avoid nested List.Generate if possible. So this is all for this video. Hope you enjoyed it. If you did, please hit like and subscribe button. If you have any questions, please post it down below, and see you in the next video. Bye.